Hello again, everybody. We're going to go ahead and get started with Chapter 9. Chapter 9 is the most important, I would say, chapter of the entire course. And the reason you might be able to use this in almost every research that you might get involved with. If you guys are going to do your master's, hopefully, this is what you need to know very good, whatever that we cover in chapter, excuse me, in chapter 9, under hypothesis testing. So let's see what hypothesis is. Hypothesis is basically any assumption, anything that goes to your mind about anything is known as hypotheses. Whatever that goes to your mind about anything. For example, whenever you hear the name UCLA, whatever that goes to your mind about UCLA, whatever that you think of UCLA, that is the hypothesis. That's what we call hypothesis. There are two different types of hypotheses. We have the hypothesis that goes to your mind immediately, or they call it in the statistics a tentative assumption. The tentative assumption that goes to your mind is known as null hypotheses. So we have null hypotheses, which is shown by H sub 0. And then there is another type of hypothesis called alternative hypotheses, which is shown by H sub A. When we are going to do the hypothesis testing, we basically are trying to see if we can establish some standards and values that we could accept this and reject this. The main idea of hypothesis testing is to test the null hypotheses to see if that is correct. If the claim or the assumption, the tentative assumption, the tentative claim, which we call it null hypothesis, if that is true, then we go and accept it. If this is not true, then we have to go ahead and accept alternative hypotheses, because alternative hypothesis is always opposite to null hypotheses. I'll give you an example. If you have an assumption about UCLA that almost all of the courses offered at UCLA, all of the majors of studies at UCLA, they are all designed based on the highest level of standards of educational code, for example. If I go ahead and find one or two cases that they are not being designed based on the highest level of standards, then I can go ahead and reject your hypotheses. Okay, this is the simplest form of the example that I can come up with. But in industry, they are using this hypothesis testing in order to test the claim of the businesses, their assumptions about their businesses. And there are three different cases, or whatever hypothesis testing that we do in business, they fall into one of these three categories. What are these three categories? Slide number 4, testing research results. Testing research results or research hypotheses. Example, I'll give you an example. This company, this automobile company, let's say that they have designed this engine, that they claim that this engine, that this engine can give you up to 40 miles per gallon based on their latest research and development. They came up with this design that this engine gives you up to 40 gallons. I'm sorry, up to 40 miles. Sorry about that. They give you up to 40 miles for each gallon of gas. Now, when they come up with this claim, they mean that this engine is going to give you maximum 40 miles per gallon. All right? Now, if you or anyone can go ahead and prove that this is not accurate, if you go and prove to these people that no, this engine can give you more than 40 gallons, then you can reject their hypotheses. But if you be able to prove that this engine is giving you up to means 40 miles or less, as long as you be able to prove that this engine is giving you 40 miles or less, that means you have to accept their null hypothesis, the alternative assumption. You might want to say that why do we even have to care about what they say, what they claim? Well, based on their claim, they will go ahead and run these commercial ads. Based on their commercial ads, we go out and we get attracted to their products. We have to make sure that whatever that they promise, whatever that they advertise, they do deliver. One of the organizations that oversees these activities is the Consumer Fair. Another organization is ISO, International Standardization Organizations, that checks all the standards that have been developed in different fields in industry. So that is one case, one of those three cases. They call it testing the research result, right? The second case of hypothesis testing is testing validity of a claim. Somebody claims something about their products. We should be able to go ahead and test and see if they are correct about their claim. Example, Coca-Cola Company claims that for every single can of Coke that you buy, they give you 12 ounces of drink or more. They normally tell you that they give you 12 ounces of drink or more, or you can say they give you at least 12 ounces. Why do they have to give you at least 12 ounces? Because they charge you for 12 ounces of drink. If they give you less than that 12 ounces of drink, then they have overcharged you and then they are in violation. So we have to go in, or the government agents, they have to go in and they have to do a sampling, and randomly they have to go in their plants, Coca-Cola plants, and they have to pick some of these cans of soda and they have to measure it to see if they do measure 12 ounces or more. So if they have less than 12 ounces in each can, or even in one can, they normally try to, the agents, they normally try to repeat the sampling to see if they will come across another case like that. If none, at times they normally forgive that and forget about that one single case. They say that this is isolated incident. But if they wanted to go by the book, yes, they are overcharging the customers and they are in violation. So this is the second case of hypothesis testing. The third test of the hypothesis testing is called decision-making hypothesis testing. This is when you test the hypotheses to make a decision, to do something or do not do something, to go ahead with this process or do not go ahead with this process, to go ahead with this purchase or do not go ahead with this purchase. Example, you go to this company and you are the purchasing agent for your company and you are buying some cases, some fixtures for some equipments for computer parts. These fixtures, they have to measure, let's say, 3 by 2 by 5. You have to go ahead and measure these dimensions. If they measure exact measurement, then you will go ahead and accept the product or you approve the purchase, you sign the contract. If they don't measure exact measurement and dimensions, then you decide not to. Or you are in charge of this production line. This production line is putting, 20 candy bars in each box. All right? Now you go ahead and take some samples at the end of the production line and you check to see if there are 20 candy bars in each box. If one box has 21 and one box has 19, for example, then in this case you have to stop the operation. You have to decide, what do you want to do? You want to stop the operation? You want to let it go? Well, you see that if there is overfilling and underfilling of those boxes, then you go and stop. You have to decide. You have to stop the operation, fix the problem, then continue the operation. Or if there is no underfilling, overfilling, no problem, you let the process continues. So these three cases of hypothesis testing needs to be written down such that the relationship is shown by the null and alternative hypotheses. For example, for the first case, which I just talked to you guys about, the testing the research result, we are going to, this is what we call it, we're going to formulate, or if we are going to develop the hypotheses for these three cases, or if we're going to formulate the hypotheses for these three cases. So formulating the hypotheses or developing the hypotheses for these three cases, the same thing. Okay? For the first case, we say that the research results H0 states that the mu is less than or equal to mu sub 0. And alternative hypothesis is always opposite to null hypotheses. So mu is greater than mu sub 0 without that equal sign. All right? Now let me spend some time on these mu's. In that example of the research result, the company claims, this is the company claim, that if you go in and if you take the average number of miles given per gallon of gas, it is going to be less than or equal, because we said they claim at the most, maximum, they're going to give you maximum 40 miles per gallon. At the most, 40 miles. If you go ahead and drive these engines, drive these cars, and you come up with the average number of miles that you get from those cars, let's say that you test like 4, 5, 10 cars, and you drive them, and you measure the mileage per gallon. You take the average of those 10 cars. They claim that it will be either equal to, this is hypothesized average, it will be equal to 40 or less. If that is the case, then they are correct about their claim. Then you cannot reject the null hypothesis. If you go ahead and find out that the average of those 10 cars that you drove, the miles that they gave you, if they are 40 point anything, like an epsilon over 40, then you have to reject the null hypotheses and you have to accept the alternative hypotheses. This is called one-tail hypothesis testing. Later on we're going to explain, I'm going to explain this more in depth and detail. So this is called one-tail hypothesis testing when we use the bull curve. One-tail, upper tail. Okay, we're going to, those of you remember from chapter 8, we're going to use that alpha in order to measure the probability, and we're going to be dealing with the upper tail. And those of you remember for upper tail, we always did 1 minus. Okay, this is the first case. The second case is validity of a claim. Validity of a claim. In this case, manufacturer or company, they claim, H0, that the mu is greater than or equal mu sub 0, and you have to prove, or whoever that runs the testing, they have to prove that the mu is less than mu sub 0. This is what they claim. If you go in and take the average of so many cans of soda, you measure the drink, the content, they claim that that measurement, that average, is going to be either equal or more than what they claim. What is it that they claim? 12 ounces. And if it comes out to be less than what they claim, then they are in violation. This is for the second case. This is called one-tail upper tail. And this is, I don't know if you guys can see this low here. If I wanted to do the curve, all right, so wait a minute, one tail lower, I'm sorry, one tail, lower tail. So we have to measure the area to the lower area of the bulk. The other case, the last one, which is decision-making case, decision-making, that is stating that H0 is stating that mu is equal to mu sub 0. HA states that the mu is not equal to mu sub 0. So you go ahead and, for example, you measure the amount of the content in this box. Okay, if it measures what they claim, if it measures like 32 ounces, then you don't do anything. You don't stop the operation. For example, if this is the production line, once you go ahead and take the average of the content of 5, 6, 10 boxes, and if it is not equal to what they claim, then you have to stop the production line and you have to fix the problem. All right, so this is called two-tail, both tails. So that is going to be half of the alpha is going to be on this side, and half of the alpha is going to be on this side. And then when we are going to do the hypothesis testing, you see that there is an approach called p-value approach. Half of the p is going to be located on this side, and half of the p is going to be located on this side in order to do the hypothesis testing. We have to sometimes multiply those p-values by 2, or if you don't want to multiply, you just go half of the alpha against half of the p-value. So we're going to talk about that in a later time. All right? But for now, what we need to do for now, up to this point, what we need to learn to do is how to develop the hypotheses. Meaning, when we read the scenario, when we read the problem, we should be able to tell which one of those three cases this scenario belongs to. Is this the case of research result, which H0 states that the mu is less than or equal mu sub 0, or if this is the case of validity of the claim, where H0 states mu is greater than or equal to mu sub 0, or if it's the decision making. So that's very important, and that is called formulating or developing the hypotheses. So the first step, we have to know and learn how to develop and formulate the hypotheses. And the only tip that I can give you about how to formulate or develop the hypothesis is read the problem and pay attention to the wording and try to understand the problem correctly. We're going to do some examples. All right? If you guys go to the PowerPoint slides, on slide number 7, they have these 3 cases listed for you guys. And there's an example that is on on slide number 8. A major West Coast city provides one of the most comprehensive emergency medical services in the world. I'm reading off of that slide. Operating in a multiple hospital system with approximately 20 mobile medical units. The service goal is to respond to medical emergencies with a mean time of 12 minutes or less. 12 minutes or less. All right? So if you want to formulate this hypothesis, you should go ahead and use the research result case, because they say their goal is to come up with 12 minutes or less. Slide number 9. The Director of Medical Services wants to formulate a hypothesis test that could use a sample of emergency response times to determine whether or not the service goal of 12 minutes or less. So this is very clear and very easy for you to tell. If we wanted to formulate the hypotheses, this is what we have to do. Less than or equal to 12, greater than 12. Okay? So this is how we develop the hypothesis for this case. I want you guys to pay attention to that equality sign.